I think you can sit on this ceramic surface now, am I right? Induction cooker, all of you, most of you seen, you touch it, this I'm if you touch this ceramic surface, you don't get any shock, no, though when you switch on, or you can sit, no problem. Switch on this and sit on this ceramic surface, nothing will happen to you. Sir, shock, nothing. So here what when I'll send a how to generate a variable magnet field. What I do, I just take simple solenoid. This is solenoid. Coil supplied with high frequency AC. This is solenoid. I think you are aware of the thing. I'll call this as solenoid. When you send a variable current through a solenoid, a variable magnet field is produced. B equal to mu naught Ni, and that B will be along the axis. And outside the solenoid also there will be magnetic field. No, I think we have discussed one numerical also. Let's not bother here. Anyway, it will be zero. We are not bothered this part. We are bothered about this particular field. This particular field will be zero. I'll agree this. So I'll give points. So that will be easy for you. So this is the point 1, which is very important for us. And this is 2. They may trouble you with this question, so it's not there in books, but since you know regarding solenoid thing, no, can be asked here. 1, 2, call this is 3, 4. So what about this field? What I'm saying is at B1 and B2. Of course, it will be little bit less than mu naught Ni, or outside put it. We know mu naught Ni by 2, and it will further decrease. Anyway, field will be non-zero. I'll pass a variable current. So this I is equal to I naught sine omega t. Look at now B1 and B2. Mu naught N by 2. I naught sine variable magnet field. That variable magnet field will link this bottom of the pan. The bottom of the pan. So it is now we know that a variable magnet field links a conducting surface. What do we get? Eddy currents. That eddy currents here, when they flow, heat will be generated because flow of free electrons will generate heat. That heat what will be absorbed by this cooking, any dish what you kept here, or water, milk, or any dish, rice, or anything that you kept for boiling. No, so that particular material will absorb that heat, and the food will get cooked here. By chance you touch this ceramic, or I am telling this, you sit on it. I think some of you are having induction cooker, induction stove. Switch on and sit it, nothing will happen. You keep your hand on this, nothing will happen. It's a shock proof. The current is what flowing here. This will be what pen will be protected, insulated. So here shock proof, nothing will happen. Even if it spills over, if it spills out, nothing will happen. Prodded, sir, I'll wooden pan, I'll take it. In wood what pen, there won't be free electrons. So what do we get? We don't get any eddy currents. So the bottom of that what happens should be made a conducting material. What shall I use? I'll go for copper. No, copper, it will have more density of free electrons. So therefore the bottom should be made like a based on, so like it should be copper. So here what happens, all the magnetic field will link maximum the bottom. So here it will be generated here. So this is the basic idea of the induction cooker, that one what we have, induction stove. So I think this was in the somewhere in the, I think, UK, one of the student in 1970s. So what happened, accidentally what happened, he got this idea, then he proposed, so why can't we go for induction stove like this, instead of LPG, instead of say like a ordinary kerosene, or with wood, with LCT also we can use this eddy currents. Then he proposed that one. So first he designed it. It was a little bit big, then later on modified. Now it's very cheaply available. No, for 3,000 it's available. This will be the future of our cooking utensil, instrument, because LPG, all everything will get over. From LCT, what happened? I can easily do cooking. That one, and it can be programmed because I can switch off. Since electric current, no, I can control it. I think you just see the induction stove, no, it offers wide varieties. For after 10 minutes, it gets switched off, means it gets switched off. And how much of power you want. So you can control how much of current flows. The how much of current, it will determine magnetic field. How much of magnetic field will determine how much of heat should be generated. Absolutely, how much of heat you want, you can control. To that extent, things are there. So here some arrows is what I'll show it. These are the eddy currents at the bottom of the pan. Good questions can be asked. These things. Now even rotating. So I took translation. No? So even if a rotating cylinder is there, there's an iron cylinder. Magnetic field, I'll link it. B equal to B naught T. I'll give angular velocity to it. Tell me what will happen to it. What will happen to its angular velocity now? Eddy currents will be set up at the bottom. Here and eddy currents will be set up at the bottom. The eddy currents are set up in bottom in such a way that it will set up an retardation. And this retardation due to what? Due to eddy currents. Because according to Lenz's law, the direction of induced current should be such that it should oppose the cause. So at the bottom there, eddy currents will be set up. On this lateral surface, it won't be there because B bar will be tangential. At this particular point, eddy currents will be set up. They will set up an induced torque. Due to that, what happened? This undergo retardation. This is what I'll use for braking. Where do we see this excise cycle? Nowadays, I think in Ohm, we do cycling. No, there are two types are there. When one, a traditional with belt or a chain one. Other is magnetic resistance, they say. There won't be any belt. The disc will be rotating. To that disc, what a pedal will be there. This will be a disc. For this, a pedal system will be there. This one. Here, I'll link a magnetic field. There's the iron disc. This iron disc. And if I introduce a magnetic field here, magnets will be there, magnet will be kept, and that magnet, if it is moved very close, far away, based on that, the flux linking the iron plate will change. This iron disc will be rotating. As you pedal, this will be rotating. And as you bring the magnets near to it, can we see anything eddy currents here? As there will be eddy currents, no? On either side of the disc, we can see the either side disc, the eddy current. That eddy current what will introduce a induced torque. If angular velocity is like this, an induced torque will come in this direction. They may ask you like this. You have to be very careful. These are all application problems. If I increase the distance between magnets, this tau I will decrease, omega will increase. If I decrease the distance between the magnets here, then the eddy current will increase, the induced torque will increase here. So like that, just by rotating knob, you can control magnetic resistance. This is what like excise cycle, what we